Hello, my name is Will Simonson, and today I'll be covering Lab 3 on black holes in Physics 1. The purpose of this lab of Part 1 is to find the mass of a black hole using a star's orbit, calculating the gravitational force acting on the star from the black hole, and partially the purpose of Part 2 of the experiment is to find the initial velocity of a spaceship on the side of a planet orbiting the black hole with the mass found from Part 1. This initial velocity is one that will allow the spaceship to get close to the black hole without crashing into it nor the planet. Fundamental principles are Newton's second law, which is F net equals ma, and Newton's universal law of gravitation. The results, we found the net force on the star and the mass of the black hole in Part 1, and in Part 2 the initial velocity of the spaceship and the closest distance to the black hole. Main idea is universal gravitation is the mass of the two objects times the universal gravitation constant divided by the magnitude of the r, or r squared, times the unit vector, the negative of the unit vector of the position. So then Newton's second law is, we set F net equal to the change in momentum over the change in time, and the net force equal to the perpendicular force of the velocity and the parallel force of the velocity. The perpendicular force changes the direction of the motion, and the parallel changes the speed. For the update formulas we use to find the position, we first found the velocity update and then plugged it into the position update formula. So then important details for calculations is F net is equal to the gravitational force. The force of gravity will change with distance, so we will change average velocity with final velocity in our calculations. We needed to use the mass of the star, the initial time, the loop time, which is 1 day or 86,000 seconds, and the universal gravitation constant. So for the first part, to find the mass of the black hole, we calculated the change in momentum over change in time, and then set that equal to F net as I explained earlier. And then using this, we calculated the change in momentum parallel to the velocity, and then change in momentum perpendicular to the velocity. And then to find the mass of the black hole, we use these and plug them in along with information provided to us initially, such as the mass. So results, we found the mass of the black hole to be about 2 times 10 to the 34th kilograms. And we found these components of the force vector on the star. So part 2, we found the initial velocity of the ship, and the initial stuff that we used are g, the mass of the planet, the mass of the ship, the change per loop of time, and the initial time. So using these, we found the force on the net force on the planet by adding the components of the ship on planet vector and the black hole on planet vector, and the total force on the ship. So then we use these to use Newton's second law and updated the position using the change in force. And then using these, we plugged in initial velocity values based on this, and trial and error, so that you can find a initial velocity with components of the ship that allow it to get closer to the black hole without crashing into it nor the planet. Some sources of error: if you run the program for a long period of time, there will be more mass values for the black hole that you can average to achieve a more accurate answer. Every answer won't be exactly the same because the initial velocities for Zipper 2 are estimated, take into account the planet's initial velocity. You could hypothetically get a better answer than the one that I found. What does this mean? the net force is all the forces acting on the system by the surroundings added together, taking into account the direction of the force. The force of gravity is the force acting on the system, and its components can be divided into the parallel and perpendicular components relative to the velocity of the system. The change in momentum is equal to the final momentum minus initial divided by time elapsed. So, I attempted to find the initial components that would allow the ship to orbit, and the closest I got was finding the y component being a little bit bigger than the initial y originally, and the x component being smaller than the planet. Thank you.